Hello, this is the second part of our lesson about quadrilaterals. In this lesson, we will learn about trapezoids and kites. So the learning goals are to understand the properties of trapezoids and understand the properties of kites. A trapezoid has two definitions. The exclusive definition says that a trapezoid is a quadrilateral with exactly one pair of parallel sides. As we see in this image, this side and this side have one arrow each, which indicates that these two sides are parallel to each other. But these two other sides are not parallel. Okay? So according to this definition, this is a trapezoid, only one pair of parallel sides. According to the inclusive definition, the trapezoid is a quadrilateral with at least one pair of parallel sides, which means that this could be a trapezoid because it has one pair of parallel sides, but also a parallelogram is a trapezoid because a parallelogram has at least one pair of parallel sides. It has two actually. So this definition includes parallelograms as part of the trapezoids. So we will be working with the exclusive definition throughout this lesson. A quadrilateral with exactly one pair of parallel sides. That's the definition we will be using for most of the properties. So right here we have a trapezoid and the parallel sides are known as bases, okay? So bases, this will be the first base or the upper base, and this will be the second base or the lower base. The non-parallel sides are the legs. So this is one leg and this is another leg. The distance between the bases is the height or altitude. That's why we draw a segment that is perpendicular to both bases to represent this height. Now let's talk about the trapezoid angles. In a trapezoid, a pair of angles that share the same base are called base angles. So right here we have a ABCD trapezoid. We draw four angles here. So A and B would be the upper base angles. They share the same base. And C and D would be the lower base angles. Again, they share this base here. In a trapezoid, a pair of angles that share the same leg are supplementary. So here, A and D, for example, share this leg here, the non-parallel side, right, to this one. So if we draw two parallel lines across the parallel sides and a transversal here, we can appreciate that A and D are same side interior angles. If you want to learn more about what are same side interior, check the presentation on parallel lines and transversals. Same side interior angles, like A and D, are supplementary, meaning that if we add them, we get 180 degrees. Here we can see, for example, if D is 60 degrees, this angle here will be 60 degrees because it will be the corresponding angle to D. And this blue angle here, angle A, would be 120 degrees because these two are a linear pair. They are on the same side of one line, meaning these two have to be 180. They are supplementary. So in that way, we can show that the blue and the red angle, A and D, together have to be 180, right? We can show clearly that this, if this angle is 60, this will be 60, and this has to be the supplement, like the supplementary angle to this one. So these two are supplementary to each other, okay? So A and D have to be 180. In the same way, we can show that angles B and C, which again share the same leg in the trapezoid, are going to be same side interior, and therefore they are supplementary. Together they are 180 degrees. All right, so that would be the property of angles in a trapezoid that share the same leg. A and D would be 180, B and C would be 180 degrees when we add them together. Now, let's talk about an isosceles trapezoid. An isosceles trapezoid is a trapezoid where the non-parallel sides, the legs, are congruent. So right here in this trapezoid, A, B, C, D, we can see that the leg AD is congruent to the leg BC. Again, an isosceles trapezoid by definition has two legs that are congruent. Okay, these two legs are congruent. The base angles of an isosceles trapezoid are congruent. So angle A is congruent with angle B because this will be the upper base angles. And angle D is congruent with angle C. They will be the lower base angles. So now that we know this information, that these angles are congruent to each other, and these two are also congruent to each other, let's try to solve this problem here. In this problem, they give you an isosceles trapezoid, and the angle T is 115 degrees. So we want to find the missing angles here. So what we do is we say, okay, we know that from this information on isosceles trapezoids, these two base angles are congruent. So R is going to be 115 degrees. And we also know, because of the properties of all trapezoids, that these two angles that share the same leg are supplementary, together are 180. So angle P is going to be 180 minus 115, which is 65. And if this is 65, angle A will also be 65, because again, we're in an isosceles trapezoid where the base angles are congruent to each other. Now let's talk about kites. A kite is a quadrilateral with reflectional symmetry across one of its diagonals. So right here we have a kite, and this is a kite because if we draw this diagonal, the left and the right parts will be mirror images of each other. Because of the reflectional symmetry, its four sides can be grouped into two pairs of adjacent equal length sides. In other words, this side and this side will be congruent. These two sides are adjacent, one next to the other, and they are congruent. And this side and this side are congruent. Again, these two adjacent sides are congruent. So in a kite, we have one pair and two pairs of congruent sides, and those sides are adjacent to each other. We can make a kite with two pairs of congruent triangles. So let's draw two right triangles here. You see these two triangles are congruent. That will be our first pair of congruent right triangles. And we draw a second pair of congruent right triangles. If we join them together, we get a kite. Okay, so basically every time you have two right triangles that are congruent to each other, this is the first pair, and this is the second pair of congruent right triangles, and we join them together, we have a kite, and we can analyze the properties more easily by doing so. So we notice that the diagonals, this diagonal here and this diagonal here, are perpendicular. We notice that the longer diagonal, this one is the longer diagonal, bisects the interior angles. So this angle here and this angle here will be congruent, right? Because this diagonal is cutting this angle in half. Same here, these two angles here are congruent to each other because this diagonal is cutting this angle in half. So the longer diagonal separates this angle here and this angle here, bisects this angle here and this angle here, separates it in half, okay, bisects it. So the next property is that the longer diagonal bisects the shorter diagonal. We can see that this diagonal here separates this shorter diagonal in half, that this length here is going to be the same as this one here. We also see that one pair of opposite angles are congruent. You see this angle here in purple and brown? This purple plus brown angle will measure the same or is congruent to this purple and brown angle here. So this angle and this angle are both congruent to each other. So by joining these four right triangles, these two pair of right triangles, we can appreciate all these properties of the kite. That's an easy way to learn about the properties of the kite without memorizing this, just by creating this figure from right triangles. Now, this is a kite again. These two sides are congruent to each other, and these two sides are congruent to each other. We're going to have two angles here. These angles between the congruent sides are called vertex angles, okay? So the angle between these two congruent sides is a vertex angle, and this green angle between these two congruent sides is also a vertex angle. The other two angles are called non-vertex angles, and these angles are going to measure the same. They are congruent to each other. Now, if we have the kite, the longer diagonal bisects the kite into two congruent triangles, okay? So we see here that this triangle on the left and this triangle on the right of the diagonal are congruent, because by definition, a kite is a polygon, a quadrilateral, where one of the diagonals is separated into two mirror images, basically into two congruent triangles. Right here we can appreciate that these two triangles are congruent. Okay, finally, a kite is a quadrilateral with reflectional symmetry across one of its diagonals, as we saw in the previous slide. So it can be concave or a dart. So right here, this one here is a kite because it has reflectional symmetry, because one of the diagonals separates this kite into two mirror images, right? It has reflectional symmetry across its diagonal. And also, it has two pairs of adjacent equal length sides. These two sides here are congruent to each other. They are adjacent to each other and congruent to each other. And these two sides here are also adjacent to each other and congruent to each other. So this concave figure is also a kite because it meets or it satisfies the definition of a kite, and it's called a dart because of its shape. Okay, so this is the first quadrilateral that of all the quadrilaterals we've seen, right? We've seen parallelograms, trapezoids, and kites. The kite is the first one in which we can make it a concave figure. Okay, that's all for this lesson. Thank you for your attention.